In addition to using the Pythagorean theorem for missing sides or using special right triangles to find missing sides, we remember that if we know the triangles are similar, then we know their sides are proportionally equal, and therefore we can use rules for similar triangles in this setting as well. So what we learn is that if we start out with a right triangle, this outer right triangle, we've got triangle ABC. And if we draw an altitude from the point down to the hypotenuse, right, it's going to break this into two triangles, right? You've got triangle 1 here and triangle 2 there on top of the original triangle. So now you've really got 3 triangles, these 2 smaller ones and the 1 larger one. And what happens is that when this altitude is drawn, you are converting this into 3 similar triangles. Now remember, if the triangles are similar, their corresponding angles are going to be congruent and their corresponding sides are going to be proportionally equal. So we can use that to find missing sides. So the first thing we might ask you is to identify the similar triangles in this diagram. Well, let's first label this large outer triangle, which kind of started it all, right? And when I label it, I'm going to label it like I'm going to make the right angle the center of the name. So I'm going to say triangle STU. So I go from the short side to the 90-degree and then to the long angle there. Okay, so that's where I get, not STU, sorry, that's where I get STR, right? Angle S to T to R. Perfect. And I know that that's going to be similar now to, let's go to, for example, because then we drew this altitude, right, at 90 degrees, and we've got triangle number 1 here and triangle number 2 here, and they are also going to be similar. So I'm going to name it the same way. I'm going to start at the small side, right, this little vertices here, so triangle T, then I'm going to go to the right angle U, and I'm going to go to the across the longer side to R. So I know that triangle TUR is going to be similar to triangle STR, and it's also going to be similar to triangle, and again, I'm going to start at the small side and go towards the right angle, so that's S. Then I'm going to go, the right angle is U there, and it goes to T. And so I know that these 3 triangles are going to be similar. Now, you might have used different letters and things like that, but what you want to know is that when you're comparing, let's say, these 2 triangles, the corresponding angles are S to T, T to U, and R to R. When you're comparing these 2 triangles, the corresponding parts are T and S, U and U, and R and T. And so it's a little bit different. It takes a little while to get used to writing it and figuring out what goes together. If your letters are in a different order, again, it just means you have to make sure that, you wrote them, the corresponding ones together, okay? So that's how we would write the similar triangles in this diagram. Now, we're going to utilize those similar triangles in a certain way, but in the middle of all that, we're going to learn one skill which we're going to apply later, and it's identifying a geometric mean. And then we're going to apply the geometric mean to those kinds of triangles that we saw in the last slide. So a geometric mean basically says if you're given 2 numbers, A and B, all right, any 2 numbers, the geometric mean of those 2 numbers is represented by the letter X, okay? And we find the mean by saying the one number over X equals X over the second number. So we start out with this proportion here. Now you can write it like this. This is one form of it. If we're actually solving, we know that cross products will get us to the next step of this, and we realize, oh, X squared equals AB. So this is a second way of writing it, And then if we wanted to know what x was, because ultimately the geometric mean is just x, I know that if I take x squared equals AB and I take the square root of it, I know that x equals the square root of AB. And so this is the third form of it. All three of these are the same thing, and I can utilize any one of these forms to find the geometric mean of two values, okay? What I do is when I'm given A and B, I use this method, okay? So this is when A and B are given, okay? And I'm looking for x, okay? And solving for x, okay? I might utilize, let's say, this method when x and either A or B is given, and I'm solving for the other letter A or B, okay? So I use it depending on the different scenarios, but basically, let's kind of solve some problems and utilize that formula now. So if I ask you to find the geometric mean of the given numbers, here's A and here's B. So again, I can either do A over X equals X over B, right? So I can say 4 over X equals X over 20. I can use my cross products, 20 times 4, X squared equals 80, X equals the square root of 80. And when I simplify this, I know it's 16 times 5, and the square root of 16 is 4. And so I get 4 radical 5, and that's the one way to solve it. The second method I showed you was x squared, because it's like multiplied, right? It's x squared equals AB. Well, then, in this one, x squared equals 20 times 4, x squared equals 80, x equals the square root of 80, x equals the square root of 16 and 5, so x equals 4 radical 5. Notice that this method just starts here. So in other words, I just skipped the first part of it. And then remember that I told you that ideally you use x equals the square root of A times B. So x equals the square root of 20 times 4, x equals the square root of 80, x is the square root of 16 times 5, and x is 4 radical 5. And again, here you just you're starting at that step there. So again, when you're given A and B, okay, instead of doing this or this, you might as well just start with this formula because it's going to get you to the answer the absolute quickest, okay? But again, you can do it either way, but my suggestion would be to start with that. So again, if I was given this problem, I would just do 4 times 20, square root of 80, which we know is 4 radical 5. Over here, again, I'm going to do this one the same way. I know it's x equals the square root of A times B. Whoops. Sorry about that. So it equals 9 times 25. X equals the square root of 225. And the square root of 225 is 15. So the geometric mean is 15. So the geometric mean is easy to find once you know the formula. So why do you think we're teaching you this here? Well, it's going to come, and you're going to see why in the next few slides. Here we learn this altitude theorem, but the altitude is really, we're applying the geometric mean, and we're calling the altitude the geometric mean. And this theorem basically tells us again that in a right triangle, we know that the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 sections. So again, notice that we've talked about this before in the beginning. We had this original triangle, and then we created this altitude, which was a line at 90 degrees. And we told you that that suddenly creates 2 more similar triangles to the original. So you had triangle 1 and triangle 2. Well, these pieces notice that this here represents the original hypotenuse. And these 2 segments in the original hypotenuse are basically, it breaks original hypotenuse into two segments. We've got segment 1 and we've got segment 2. And so now we're going to use the geometric mean. The altitude, we're going to call it the same as the geometric mean, which you know is x. And so we know the formula, okay? Segment 1 is going to be like our A, and segment 2 is going to be like our B, and the altitude is our geometric mean, or our x. And so remember before it was A over x equals x over B. Well, we're just replacing A with segment 1, x with the altitude, again, and segment 2 with B. So if we know the pieces, we can plug it in and we can end up solving this question. So let's solve it on the next page. So here I want to use the geometric mean formula again, but I'm going to use it for the leg theorem. And so what happens here with this is that the geometric mean, which we know of as x, also applies to the legs of a triangle. So just like I used it with the altitude, I can use it with the legs. Now again, I'm going to start with my original right triangle. It should look like that. And then I know that an altitude, this is still the altitude, an altitude was drawn from there. That altitude broke this hypotenuse into segment 1 and segment 2, also known as A and B. It also broke this into leg 1 and leg 2. And so we now have another way of utilizing our mean formula. Remember, our mean formula is going to involve a proportion. So we know that the ratio, all right, we're going to use these signs. We've got the entire hypotenuse over leg 1 or leg 2. We're going to pick a particular leg. The hypotenuse over a leg equals the leg times the segment of the hypotenuse adjacent to that leg. Now that kind of makes it a little bit weird, right? So if I'm talking about leg 1, we're talking about segment 1. Okay, so let's kind of focus on that. So what I do is I'm going to look here and I'm going to say, okay, I've got my geometric mean part, the x part is leg 1, right? So leg 1 goes at the bottom and leg 1 goes at the top. And so what are the other two values? Well, the hypotenuse is one of them and segment 1 is the other. It's this piece and it's the hypotenuse, which is both, okay? So if I'm working with leg 1, I'm focusing on segment 1 that's on the same side. Notice these are all parts of the same triangle. So the other one, if I wanted to know, let's say leg 2, it would be the hypotenuse over leg 2 equals leg 2 over segment 2 would be this piece. And so that's kind of how we would do it. So if I was utilizing letters here, right, the way they do, they make the hypotenuse equal to C, right? So notice it's hypotenuse over leg 1 equals leg 1 over segment 1. And if I'm doing the second triangle, this triangle 2 here, it's going to be the hypotenuse over leg 2 equals leg 2 over segment 2. So it's the segment that goes on the same side as the leg you're looking for. And again, let's try to actually work that out in a subsequent problem. Let's actually do this one first. We'll go back to the other slide in a minute. So it says here, if JR is equal to 16 and EJ is equal to 9, find HJ. Then it wants us to find RE, RH, and HE. But right now, we're just going to focus on this. We have our original triangle, we have our altitude here, and we know that this geometric mean, this is segment 1, which is our A value, and this is segment 2, which is our B value. And so we know that the formula for this is A over X equals X over B, right? So we can plug in these numbers. We've got 9 over x equals x over 16. X squared equals 16 times 9. X squared equals 144. And when we take the square root of it, we get that x equals 12. So guess what? Our altitude, which is also in this problem our geometric mean, is equal to 12. So HJ here is 12. Now, again, if this is the geometric mean formula, you might say to yourself, well, why then did I put it in a proportion, right? If I'm looking for x and I've got a and b, isn't it quicker to just do x equals the square root of a times b? It absolutely is. And so I know that I could have just started with x equals the square root of 9 times 16, x equals the square root of 144, so x equals 12. And that would have been a little bit quicker. So yes, I can apply my strategies here and I can solve for this. So now I'm going to go back and teach you another theorem that's going to help us answer the other questions in A, and then we'll put it all together and solve for, I guess this is B here, is what should be there. So we got one value. Let's go back a couple of slides. So we're going to come back here and notice they want us to find RE. Well, RE, first of all, RE is just the hypotenuse, right? So once I knew it was 9 and 16, I know RE is 25. So that one's kind of easy. Now I'm looking for RH. Well, RH, I'm going to call this leg 2. I'm going to call this side leg 1. This is segment 1, and this one's segment 2. So if I'm looking for leg 2, I know that I'm going to use the geometric mean formula. I'm going to do hypotenuse over leg 2 equals leg 2 over segment 2. And so when I come over to here, my hypotenuse is 25. Leg 2, I don't know what it is. It's RH, right? And leg 2 again is RH again. And then segment 2 is 16. So I know that RH squared, whatever that is, right, is going to equal 25 times 16. So RH squared is going to equal 400. And so the square root of RH squared, RH, is going to equal 20. So I know that segment RH equals 20. So 20 units. And I'm going to utilize that same strategy so that I can solve my last piece, which is HE. And again, HE is talking about leg 1. So again, in this formula, right, I'm going to do hypotenuse over leg 1 equals leg 1 over segment 1. So my hypotenuse is still 25. Leg 1 is EH. I don't know what that is. So EH, the length of EH, and again, segment 1 is 9. So I'm going to get EH squared equals 9 times 25. EH squared equals 225. And I know that EH is going to equal the square root of 225, which means EH equals 15. And so EH or HE equals 15 units. And I now found all the pieces to this problem using those proper formulas. So again, you have to understand what segment 1 is, segment 2, leg 1, leg 2, and the altitude, and understand how each part plays its role, okay? So you're applying the geometric mean to the altitude in some of them, and you're applying the geometric mean formula to the legs you're looking for in others. So now we'll go through and we'll start to solve the other problem there. So I'm going to erase this and work on the next problem. So let's start with the first value. So again here it says that JR is 4. So this segment 2 is equal to 4. JH is equal to 2. So my altitude is 2. Find EJ, which is segment 1, right? And I can give it variables. I can do X, for example, or whatever. I kind of like just writing EJ, so I think I'm going to keep doing that. If you want to do variables on yours, you can. RE is going to be the hypotenuse. Okay. I've got RH is going to be leg 2, and HE is going to be leg 1. So now I have it properly labeled and I can start solving. So first things first, I'm going to start trying to find segment EJ first. So I know, again, and I'll just set it up as a proportion. I know that my altitude, right, it's going to be segment 1, which is EJ, over my altitude. 2 is going to equal my altitude over JR, which is 4. My segment 2. So segment 1 is EJ, segment 2 is 4, and now I'm able to use my cross products. So I get 4 equals 4 times the length of EJ, and if I divide both sides by 4, I get that EJ equals 1 unit. So EJ is 1. That's my first answer. And if EJ is 1, then my hypotenuse is 5. So RE here is going to be 5. My second thing now is I'm going to start to find RH, which is leg 2. So here I'm going to do leg 2. So I'm ready to do the hypotenuse over leg 2 equals leg 2 over segment 2. So my hypotenuse I just figured out was 5. Leg 2 is RH. I don't know what that is yet. And that's going to equal RH over segment 2, which is 4. So I know that RH squared is going to equal 5 times 4. RH squared is going to equal 20. So RH is the square root of 20, which is the square root of 4 times 5, which is 2 radical 5. So 2 square root of 5 is the length of RH. And now I'm going to utilize those same skills to figure out what HE equals. So again, HE is leg 1. So I know my formula is going to be the hypotenuse over leg 1 equals leg 1 over segment 1. So my hypotenuse is 5. Leg 1 is HE. I don't know what it is. And that's going to equal HE again, all over segment 1, which is 1. And so again, I'm ready to do HE squared equals 1 times 5. HE squared equals 5. So HE equals the square root of 5. So square root of 5 is the length of HE. And so I was able to find all the lengths using the ratios. So once again, remember, if I'm just using geometric mean, right? If I'm just using the formula for geometric mean, I know that it's going to be A over X equals X over B. I know that I can write it as X squared equals AB, and I can do X equals the square root of AB. Now, if I want to use that with altitude, right? So if I want to do geometric mean with an altitude question, I know again that my A is going to be segment 1 over my altitude equals my altitude over segment 2. So just doing the same skills here, if I go from here to here, I'm just multiplying it. So I know that altitude squared is going to equal segment 1 times segment 2. And again, if I take the square root so that I can get the X by myself in the mean, if I did the same thing here, then I know that the altitude would equal the square root of segment 1 times segment 2. So this is 3 different ways, again, of writing it and solving it. I kind of did them all as proportions, but you don't have to do that, right? And if I was using the geometric mean with the leg, right, geometric mean with the leg theorem, then how that works is, again, it's going to equal, first as a proportion, I could do, it's going to be hypotenuse over leg 1 equals leg 1 over segment 1, because that's for one leg. So again, if I take that, I know that leg 1 squared equals hypotenuse times segment 1, and I know that leg 1 will then equal the square root of the hypotenuse times segment 1. And with that, if I'm looking for leg 2, I'm just going to replace and do leg 2 equals leg 2 over segment 2. And again, I can do leg 2 squared equals hypotenuse times segment 2. Whoops. And I know that if I take the square root of both sides, I'm going to get leg 2 equals the square root of hypotenuse times segment 2. So it doesn't matter which formula you want. It's all kind of the same idea, but you just want to know, again, if you just want to go straight into leg 1 and leg 2 with a square root, altitude, and mean, you would use that one. That's kind of the comparable one. If you want as a proportion, you would do this, you would do this one, and this one, right? And if you want that middle phase, then this one would go with this, would go with that and that. And again, they're just progressive. You go from this to this to this, and you do the same thing here. It's just different processes of solving it. But those are the ones you want to focus on, and that's what you need to kind of memorize.